one of the important evidence for the particle theory. So question number 19, which row is correct for evaporation of a liquid? Guys, this is again the same question, I mean exact same question. So question number 19, again the answer is C. Somehow it is repeated again. Question number 20, a cylinder of constant volume contains a fixed mass of gas. The gas is cooled. So whenever you're reading questions like this, it's going to be repetitive. So the gas, you have to highlight the main things. The volume is constant, temperature is decreased. What happens to the pressure of the gas, and what happens to the kinetic energy of the gas molecules? Same question, same. It's a very small topic. A small topic in the sense the theory is very simple, so there's nothing complex to be asked. So pressure, so it's cooled, temperature decreases, kinetic energy of the molecules decreases. That takes off the answers B and D, and that leaves us with A and C. Again, pressure, it's moving slowly, so less number of collisions per unit time. So again, pressure also decreases. Answer A. Question number 21. A swimmer feels cold after leaving warm water on a warm, windy day. Why does she feel cold even though the air is warm? So perhaps the swimmers, Himesh, Imad, I think you can relate to this question. So even the day air is warm, still a swimmer feels cold after leaving warm water. A swimmer feels cold after leaving warm water on a warm, windy day. So he is leaving warm water in the sense not hot water, but like warm water, but like normal temperature water, but the air is also normal temperature, but he feels cold because what happens is the less energetic water molecules on her skin escape quickly. Now, less energetic can't escape, they can't become gas. The more energetic water molecules on her skin do not escape. If it is more energetic, they are bound to escape. So that's also wrong. The water on her skin does not evaporate quickly enough to keep her warm. Now, during evaporation, the temperature of the remaining liquid reduces, which means that in turn your body is going to supply the remaining liquid heat, so your body's temperature is going to decrease, right? So listen to that again. So during evaporation, the temperature of the liquid reduces, of the remaining liquid reduces, which means that your body is going to supply the remaining liquid. The heat energy from your body is going to flow to the remaining liquid, which means that your body temperature is going to decrease, right? So I think the answer D, the water on her skin evaporates quickly and cools her skin. Yeah, that's right. So how it cools it? This is what happens. As I said earlier, the average kinetic energy decreases, so remaining liquid temperature decreases, heat goes from your body to the liquid, so your body temperature decreases. So answer for 21st is D. 22nd question. The diagram represents the molecules in two different states of matter. The arrows show the motion of the molecules. What is state 1 and what is state 2? So in state 1 it is random, and there are only less number of molecules, the density is less, so it is obviously gas. But in state 2 you can see that the arrow is in both the directions, which means that the particle is vibrating. The particle is vibrating, not like moving randomly, it is vibrating. So that's why the arrow is in two directions. So this vibration from a fixed position happens in the case of solids, so it's gas and solid, so the answer is B. Question number 23. The water in a lake is at 5 degrees Celsius. A diver measures the pressure of the water at two different depths in the lake. He repeats the measurements on a different day when the water is 15 degrees Celsius, so the temperature has increased. The density of the water decreases when its temperature increases. Which combination of depth and temperature produces the greatest water pressure? So you know that pressure in a liquid is given by H rho g. Now when the temperature increases, density decreases. To have the greatest pressure, we should have the greatest depth and greatest density. So greatest density means lowest temperature. So the lowest temperature is 5, and in 5 you need to have the greatest depth, so 20. So the answer is C.